Hello, everyone. My name is Michal Cyprian. I work at Kiwi.com as an engineering manager. At Kiwi, we use Python to build innovative app for travelers. We are a tech travel company based in Czech Republic. The story I want to share with you today is about the transformation of our ways of working and our engineering practices we did last year. The story starts on one Friday afternoon. I was slowly finishing my to-do list and thinking about my weekend plans when an ad hoc meeting appeared on my calendar. We know these situations, it's usually not a good sign. And it was just me, my product manager, a senior designer from very far in the company hierarchy, and another senior product manager at the call. The senior designer explained that an airline partnership project has just escalated, and there was an enormous business value in it for both sides. So we were supposed to start working on it immediately. Can we deliver an MVP in 3 weeks? He asked. So we dived into the requirements of this MVP, and it turned out to be very, very complex. First of all, we needed to involve 18 engineering teams to build the whole feature. There were quite complex changes, both on the user interface and also the business logic across the whole flow. Short after the launch, we expected 30,000 unique visitors per day in the flow. And the biggest problem of all, this 3 weeks deadline to build it all. In these situations, the job of an engineering manager is typically to estimate the complexity of the feature. And with my experience, including some high-pressure emergency projects where the time to production was critical, this one seems like a clear call. Impossible, I said. 3 weeks are not enough, not even to translate all the new copies we need for the flow. This was definitely impossible with our old ways of working at the company. So if we wanted to take a chance to succeed, we needed to make dramatic changes. This is how our quarterly planning typically looked like. There were like many people, many opinions, a lot of negotiations that we will do this feature in this quarter and the next one needs to wait because we have these 3 teams working on something else. Does anybody know similar environments? Can you raise your hand, maybe? Not too many people. And what do you think? Like, do you think this setup is not optimal, that the changes can take a long time when we do it this way? Maybe some hand somewhere. And who thinks that this one cannot work well in the emergency situations when the speed matters a lot? I would say that at the time of crisis, we need the strong leaders to step up, make the right calls, and lead their teams straight to success. We don't have time for these long discussions. And that was sort of our approach. The first one was that the decision-making was more centralized on the senior level management. Often it was the CEO directly was really putting together this vision that this is the next thing we need to build, the next priority. It was more top-down. So instead of all the teams discussing it, the top management decided that this partnership is the top thing. Everybody who is involved needs to take it as the #1 priority and use all the resources to deliver it. So we had this top-down approach, and the priorities were more synchronized. And to be more efficient in communication, because as I mentioned, there were 18 teams needed for this feature, we built what we call mission-aligned teams as well. We can take a closer look at the mission-aligned teams. Yes, this is our traditional team setup, that for each domain, the search, booking, and so on, we have one team. Those are the experts on the domain, and they typically maintain it and build new features there. As like here, we needed to build the whole flow. We blurred those boundaries a little bit, and then we built these cross-functional mission-aligned teams. So we put together the experts from all the domains we needed for the partnership project. We created this artificial team on top of the structure, and we have this strong mud lead who is the owner of the whole thing, who is in charge. The team is like having calls daily if needed, and they have clear focus on this one project for the time period. Once the project is finished, the mission-aligned team is discontinued, and we can again use the resources to build new mission-aligned teams for new projects. So with this new setup, as I mentioned, the top-down approach, the synchronized priorities, and the mission-aligned teams, the decision-making process before it was typically, I don't know, 3 weeks to agree on the resources to set the priority. Now it all happened on the top level, and from our perspective of our engineering team, it was effectively immediate. We simply took the list from the CEO. Number 1 is the partnership project, so we do the partnership project. No discussions, we just like start building it. This is how we improved or reorganized the communication people around the project. And the second, I would say, game changer was to utilize the best technology, the best tools out there, and use them for our advantage. So we also did some research, and it was already 2024, and the rise of AI. So we tried different tools, and we tried to integrate the best AI tools into our processes. The typical bottleneck for these high priority projects was translations. You have a new UI copy somewhere in the app. It needs to be translated to 25 languages. This takes 14 days typically. With the new AI translations platform, it was ready in 24 hours in, let's call it, a reasonable quality. And similarly, we started using AI tools for quick prototypes, UX prototypes, and for the development, typically the Cursor, IDE, and Cloud Code. And with all these things together, the delivery of this MVP before roughly 10 weeks is optimized to 3 weeks time, just what we needed for this partnership project. So 3 weeks are over, and we have the heavy development mostly finalized. And there is no much time for, let's say, pre-production testing. So what we did was just several end-to-end testing rounds on the flow. And then we did some launch on very small traffic. We picked one route first. We released it. We waited for a few bookings to go through. We fixed the bugs and iterated this way. And once we got some confidence that bookings are going through, we gradually rolled this out to the significant traffic. And it's time to celebrate and announce it. Let your team rest a bit and enjoy this moment. So the business requirements are now satisfied, and our users are happily making their bookings. But our job is not over yet. As we were moving at this rapid pace, we needed to take some shortcuts, do some quick decisions. There was no too much time for this, what we call the proper engineering practices, to think about extensibility, good design, and stuff. So now it's time to pay the debt. As I mentioned before about the rise of AI, we took a similar approach also when it comes to the development process. We tried, benchmarked several tools, and 2 of them I think are currently the best. First one is Cursor IDE. It's built on top of Visual Studio, and there is a LLM agent chat integrated on top of that code base, in the context of the code base, and we can ask questions to get some insights about the code. We can give the LLM agent tasks to do some small refactoring or some bigger features. So that's number one. This is currently our default IDE for every developer at the company. And the second one, Cloud Code from Anthropic, also built on top of Anthropic agents. And the interface is much simpler. It's technically just the terminal command style tool, which can be limiting in some cases, but it can be also an advantage. For example, if you want to integrate it into some fully automated solution, you can install Python SDK and use Cloud Code somewhere in your stack easily. Our initial experiments with these new cool AI tools looked similar to this one. Simply zero-shot prompt. I have an agent, so agent, build me this cool feature. And this was the result. You can take a quick look. Pretty bad, isn't it? This kind of a spaghetti code, we don't want it in our repo, not even as a temporary workaround. So no, this is not the way. So what we did next is that we took a look at our whole software delivery cycle. And for each phase, we did some analysis, we tried out the tools, and we tried to find the best ways to integrate AI into the cycle. The first step is to specify the requirements. Here we need the humans to explain what we want to build or refactor. For small features, it's enough to write it into Jira. For some bigger features, we typically need a product requirements document or some design documents to have the requirements clearly specified. Even here, we can use LLMs for ideation or to, I don't know, put it somehow together, but it's mostly human task. Then we can move to the analysis and the design phase, and this is where our little agentic friend appears on the scene. And our job is mostly to collaborate with the agent, iterate, and build together some breakdown of steps, and also explain not just what, but how we want to build this. And typically, we need to provide relevant context to the agent. What we can do when refactoring, the code we want to refactor will typically be the artifact. For the code bases, we build some baseline rules for the agent in form of Claude MD file or cursor rules that we iteratively improve over time to give it some best practices, what libraries to use, and so on. And then we can do more stuff. We can give it our requirements or our Jira description. We can use a plan mode and let it understand certain pieces of the code better before we continue. What is important here is to choose wisely what belongs to the context and what not. Because, of course, providing relevant context will improve the result, but when we reach certain amount of the tokens, the quality of the result goes down. So it's a relatively precious resource, and if we feed there too much, the agent can be confused if this context is what they need to finish the task or it's something else. Now we are ready to move to the coding phase, or maybe better to call it the code generation phase. And this we can imagine as, or understand as, some kind of a pair programming exercise. There are two basic approaches. The first one is that the human takes the role of the driver. Human is the one writing most of the code. And the agentic AI is our observer. They can make suggestions, or we can ask them questions, but we still write most of the code. Or what is interesting, we can try to turn around this concept. We can become the observer, let the agent build the stuff, generate the code, and we are just like giving it commands or like iterating, improving stuff, become the observer. And if we put together a well-defined prompt or task, we can get lucky and have time to grab a coffee in the meantime while our agent is coding for us. When we have the code, we go through the code review process, and this is again where agentic AI can bring good results. What we did is that we integrated Claude Code into GitLab, and when we publish merge request, we can just tag it, and it will do extensive code review, sometimes make suggestions that we can apply right away, or we can take the review and again use Cursor IDE or another agents to address the issues. When it comes to testing, this is again interesting. Let's say we need to refactor some code base with a good test coverage. What typically works well, that we give the agent some instructions, like what we want to refactor, what the new interface is to use, and we can let it work. We can teach it how to run the test suite for the project, and we can give it instruction to work on the refactoring until all the tests are green. Give it this kind of a self-reflection loop when agent will build something, run the test, okay, this is failing, analyze the test errors, and go on and iterate until these success criteria are satisfied. And once we pass the test phase, everything is green, the code quality is reasonable, there is this final stage, and then it's again a human who needs to take the results, the artifacts, and see the feature deployment and make a decision whether this is good enough to be promoted to production, or we can decide to restart the whole cycle with better specified requirements or different requirements for the agent. Yeah, like in this process, we typically invest a lot of our time and energy into prompts, and at the end of the session, prompts are gone, we discard them, which is sometimes not ideal, because then we might want to reproduce the process or share with our colleagues how to do it. So what became popular recently, this year, is to replace most of the prompting with specification files. So instead of building, optimizing the great prompt, so the prompts have a lot of information in it, and we typically clean the context at the end of the session task, and it's all gone. So instead, we can write a specification file, which is a regular markdown file, where we specify the requirements. This is what we want to build. This is how we want to build it. These are the existing dependencies in the repo. I want you to build this interface with complete instructions, and typically a list of tasks, what to do in which order. We write it as a markdown file. We can also interact with the agent in this process. We can give it a brief idea, let it generate the spec for us, and then edit the spec or ask it to edit it in a specific way. And at the end, we have this very precise, clear definition of what we want to build. And then we ask agent to execute it. And what is the advantage? That this specification can be versioned in our Git and can serve as a documentation in the future of what was built, what were the reasons, what were the user stories, which brings us to what is called spec-driven development with agentic AI. So this is basically how our day-to-day development, software development cycle looks like these days. And we are still not happy. We want to bring it even further. And what we are working on now is that we provide agents with a couple more integrations, typically some MCP servers. We can let it read definitions from Jira. We can connect it to database replica to get access to production-like data. We can integrate it with GitLab, MCP, and let it publish merge requests and stuff. And this way, we can technically eliminate human participation from the right side of the diagram, and let the agent do the stuff. We will just like specify the requirements, say what we want in form of a prompt, spec file, or Jira description. Then we let agent do the coding part, and then we see the result, and we say that we are happy with it, or we restart the cycle and iterate. And what is interesting about this one is that now the human job is to specify requirements in human language, and then take the result, try it out, and say if it's good or not. So this enables even less technical or non-technical people to contribute to the product this way. This is in sort of an experimentation phase at the moment. We have some smaller use cases. Let's say we let agent to build SQL queries on top of an analytical database, or to prepare merge requests with some infrastructure Terraform changes that we then carefully review and we promote the changes and stuff like that. And if we succeed to break through with this one for more complex use cases, I will tell you more about it next year, maybe. And this is how we did it. This is the deliver, deploy, refactor, repeat story. The main takeaway, I would say, is to always try to synchronize priorities with the other depending teams. Typically maintain ordered list of 3 to 5 things we focus on at the moment. If it's a really like business critical thing, focus on satisfying the business needs, make users happy first, and introduce some tech that makes some shortcuts, and then refactor, address them. And experiment with AI. There is a lot of new stuff, a lot of stuff going on. And some of these things can really make you more efficient, faster. And it's also fun to experiment with it. And yeah, don't skip the refactor step in the cycle. That's important as well. So if you get invited to similar Friday meeting, remember this talk and try it out yourself. If you have any questions, I will be happy to answer them now. Also, feel free to reach out on LinkedIn, or you can find me tomorrow near the KiwiCom booth as well. Thank you.
Is there any question?
Yes, so for how long have you been applying this kind of life cycle to your development, to your feature development?
I'm not sure if I'm prepared to this one, but I would say mid-2024, we have started with some experiments. So over the year, and now I would say it's a standard, like every engineer at Kiwi uses Cursor IDE, and like it's still the choice. You can be the driver and let the AI just apply suggestions, but we have people that write code using plain English with Claude whole day without even like understanding the code deeply.
And so far you haven't seen like an accumulation of technical debt that might like come to bite you in the ass in the future, or?
Oh, that's an interesting one. Like there were some issues involving some like security issues and stuff, but we always like have the HackerOne checking it. There are some security audits and stuff, but I think it always depends how much effort you put into that final stage where you can do the code review deeply by humans at the end, make sure it won't get through if it's not good enough. So it depends, I would say, feature by feature. Sometimes we have the backend SDK where the security and everything is set up, and we just want to build some quick front-end prototype on top of it, some thin layer. So in those cases, if it's some prototype to try it out, to show the user, it's fine to let Replit or Claude generate it. If it works well enough, it's fine. So I would say it depends on the use case, but this is definitely something to focus on when experimenting with vibe coding and agentic AI, that's for sure.
I think we come from a place of fundamental disagreement here, but I'll not belabor my point and leave the stage for someone else.
Anyone else wants to? Okay, well, thank you for...
Thanks.